So, hello. I'm going to present you the work that I did during my master's final internship at CREATIS Lab. So I worked on the impact of magnetic resonance sequences choice on deep learning segmentation of muscles. When a patient undergoes an MRI screening, a magnetic field is applied on the desired part. And thanks to this procedure, we can get different types of images. In particular, with a method that's called the Dixon method, we get 4 types of images that will put forward different information in the biological tissue. So here, the T1 water image puts forward the water molecules of the image. The T1 fat, it's for the fat molecules. And then in phase and out of phase are basically combination of those 2 images. During longitudinal studies, it's important to have a segmentation of some tissues, of some volumes. So here you have a segmentation of the quadriceps muscle. However, manually segmenting those volumes is a very tedious task, since you can have like volumes 100 pixels times 100 pixels times 100 pixels, and therefore it's very useful to have an automatic way to segment the muscles. And it's actually something that was already done with deep learning methods. However, when working with Dixon image like those, only the T1 water image was used, and the other 3 images were not put to use. And so what we wondered during my internship was whether using all of the images available, all of the information available, combined could improve the results that we have with deep learning networks. So I worked with 2 UNet-based networks. So these are convolutional neural networks. I wanted to compare them. They're pretty similar, except that the part where the images are combined are different in the network. So here it's combined at the very input of the network, and here it's combined a bit later. In order to compare, so the information that we can get from the different types of Dixon images, I tried different combination at the entrance of the convolutional neural network. So I tried only one, every image separately. I also tried every pair of images, and I finally tried all of the images all together. And I also didn't say, but the late fusion network is said by literature to be more effective than the early fusion network. However, it has more parameters, so it was interesting to see whether we could get similar results with the early fusion UNet. So these are the results that I got. You can see that visually it's very satisfying when we compare it to the ground truth. The muscles are globally very well found by the network. There are still some parts that require some improvement, but it's overall very satisfying. When we look in more details into the results, we can notice that we can classify the results, the combinations into 3 types of combination. And I will focus mostly on the best cluster part. So this best cluster has the highest mean values and the smallest standard deviation. And actually what was interesting was that all of the combinations that belong to this best cluster all have the T1 water image. And it's always the T1 water image combined with the other types of images. And however, in order to find one best combination among this cluster was more difficult, since it wasn't there wasn't a significant difference big enough in order to really conclude on the best combination. So in order to conclude on my work, I found that the optimal Dixon image for segmentation task was T1 water alone or combined with other Dixon images, and that when we compare the two early or late fusion network, there wasn't also significant differences despite the optimization of hyperparameters. Since the late fusion UNet has approximately 2 times more parameters to train than the early fusion UNet, it's better to use the early fusion network for our specific case. I could work also later on the network's explainability, wondering why we don't get better results when we combine all of the images together, whereas there is more information for us. And also, if you're more interested, there is a paper that I published for a conference, so if you have more questions about that. So thank you for your attention. Do you have any questions?